Hip-hop music is filled with popular phrases and quotables. Some of the most legendary and iconic terms synonymous with the human language have stemmed from some of your favorite rappers. But perhaps the most chronicled of all quotables deals with the physics concept that we experience daily: being down. Whether it's down for the cause or down for the ride or simply just wanting to know how it's going down, the mention of being down sparks more scientific concepts than you may think. The phrase 10 toes down refers to one's ability to keep it real, to stay true no matter what outside forces are acted upon them, which brings up some rather complex applications that may have you looking at what it means to be down from a whole different perspective. So, just how down are you? Are you Nicki Minaj down?
It's going down, basement.
Yo Gotti down?
Go down in the deal.
Or perhaps DJ Khaled down?
I'll hold you down.
Well, one element that certainly has down written all over it is a force that's commonly misunderstood. A force that keeps us all grounded, yet on the subatomic scale bears little to no weight at all. Gravity. Gravity is responsible for the balance of our universe. It's the reason why 8 billion of us are able to walk on Earth as it rotates and revolves around our sun. Yet given all this power, it still remains one of the most falsely represented and mysterious concepts known to all of science. So to clear up all misconceptions and get down to the core of what gravity is, let's analyze 3 notorious misunderstandings about our universe's most fundamental force. One would think that a mysterious force that's able to keep the likes of Rick Ross and 2 Chainz grounded would be incredibly powerful. Every day, forces are acting all around us in every possible direction. When you're listening to your favorite album, watching your favorite television show, at the gym hooping or working out, there are standard forces, those that we call fundamental, that govern everything that happens throughout our universe. The strongest of these, appropriately known as the strong force, is what binds particles on the subatomic scale. The very quarks that make up protons and neutrons are held together by this force. Though all of us are made up of atoms, we never actually feel this force due to the scale of its interaction, since it only works within the nucleus of an atom and not at a distance. The next strongest is a force that affects everything, from the driving capabilities of Jay-Z's new Rolls Royce to the Yeezys on your feet. Every day, things are affected by this force, and it's the driving force behind friction and the ability for solid objects to take shape. This force has to deal with the interactions between charged particles and is thus described as the electromagnetic force. It's composed of both the electrical components of particles, which can attract or repel each other, and the magnetic components, which can develop a magnetic field as they move. The weak force, contrary to its name, still acts at the subatomic level, much like the strong force. However, it's mostly responsible for the natural radiation that occurs in elementary particles. This force dictates how nuclear reactions such as nuclear fission and fusion take place. The natural breaking down of particles over time is influenced by this force. Yet unlike the electromagnetic force, it only acts at very short distances on the subatomic scale. This leaves the weakest of all forces as our last fundamental force, the force that dictates the orbit of planets and the movement of other objects around every star in our universe: gravity. The 1/1,000,000th of a millionth the strength of the strong force, what makes gravity unique is the fact that it's associated with objects that have mass. So whether it's Joyner Lucas's SHERP ATV or exoplanet Kepler 22b, gravity on a scale that we can interact with can feel incredibly powerful, yet be incredibly weak on our fundamental scale. Just like the electromagnetic force, it acts at a distance, which in theory stretches out to infinity. This talk of theories leads us to another common gravity misconception that's far more puzzling than even its weakness. What goes up must come down. We all learned this standard principle as early as preschool, and it's one of the most fundamental statements that we hold on to as we get older. The image of Sir Isaac Newton having an apple fall on his head further ingrained this philosophy in our minds whenever discussing the concept of gravity. Though at the most basic of levels to be true, This way of thinking has led us to believe that gravity is a fairly simple force, one that enables us to keep 10 toes down and justifies why every object that goes up must eventually come back down to earth. But in the words of the classic Wu-Tang anthem, gravity is far from basic when it comes to how it functions. Newton was the first to conclude that gravity was directly correlated to the mass of an object and its proximity or distance to other objects. This was reflected in his universal theory of gravitation. This theory states that any particle of matter attracts another particle with the force directly proportional to the product of its masses and inversely proportional to the square of the distance between them. This theory was revolutionary at its time and still holds true to this day, helping scientists to better understand phenomena like ocean tides and calculating the trajectories of rocket launches. Everything seemed to be standard and consistent with mathematical constants used to describe the effects and changes in motion due to gravity. Yet certain mysteries still remained that began to fray the edges of this long-standing principle. Things like the strange orbit of Mercury and the shifting of various planets' orbits over time. This led to the introduction of a new theory from physicist Albert Einstein that reshaped everything we thought we knew about gravity. Einstein theorized that instead of some attractive force dictating the movements and interactions of large planetary objects, that gravity was instead a property of the universe, a property that bends the very fabric of space and time. His theory showed that objects like our sun don't simply just attract planets to it, but instead curve the space around it, thus distorting all nearby celestial bodies. This theory not only explained the strange behavior of Mercury, but also led to the prediction of new space phenomena, like black holes. The concept of this four-dimensional warping due to the presence of mass and energy, creating a curved trajectory of anything that tries to travel in a straight line through the universe, is by far a most complete explanation of what gravity truly is. This theory is the equivalent of listening to the likes of Lil Uzi Vert all your life, and then all of a sudden being introduced to Royce da 5'9's entire catalog. Gravity ain't all that simple. Okay, all this gravity talk is cool and all, and I know we just got a little complex with black holes and quantum physics, so you're probably wondering, how do these effects of gravity apply to my everyday life? Well, you like to drink, right? Okay, maybe not this. How about we find some cleaner water? Fresh ocean water. But you're probably wondering, how does water have anything to do with gravity? Well, here's a simple experiment that you can do on your own, and you don't even need the ocean to do it. All you need is a styrofoam cup, a pencil or a pointy tool, and some water. Poke a hole in your cup, and while keeping the hole covered with your finger, fill the cup with some water. When you release your finger, you'll notice a stream of water pour out from the hole. This is due to the force of gravity acting downward on your cup, creating water pressure that forces your liquid through the hole. This same water pressure created by gravity can be seen in places like this, the deep sea. At the surface of the water, the pressure is light and easy for you to swim in. However, when you get down deeper, you're not only feeling the force of gravity, but also all the weight from the water that's above you. Now, try this experiment again, except this time, when you release your finger from the hole, drop your cup at the exact same time. You'll notice that as your cup falls, no water is released from the hole like before. This is due to the concept known as weightlessness. The force of gravity acts equally on both your cup and the water, and they fall at the exact same speed. This means no extra weight acted upon the water in your cup, thus no pressure to push the water out the hole. This concept of weightlessness applies to many more everyday things than you may think, which leads to my third and final common misconception about gravity. We've all seen images and videos of astronauts in orbit on the International Space Station and even on the moon. These images of astronauts floating has led to the misconception that there's no gravity in space. However, contrary to popular belief, gravity exists whether you're on the ground or 250 miles above the Earth. The sensation that astronauts actually experience is known as weightlessness. This feeling can differ depending on whether you're on Mars, on the moon, or in low Earth orbit on the ISS. What feels like the lack of gravity is actually the absence of contact forces. When you're on the ground, normal forces are acting upon you, thus balancing out the force of gravity. When you get launched from a rocket into outer space, however, your body goes into a state of constant free fall. This means that gravity is still acting upon you. It's just the only force that's being exerted as you hurtle your way back down on a trajectory toward Earth. The feeling is the same as when you reach the peak in a roller coaster. On the way up, you experience G-forces that press you against your seat. But at the height of the roller coaster, your body feels the sensation of your stomach dropping. That feeling is weightlessness. And if not for your seat or the normal force holding you down, you'd be floating in the air, just like an astronaut. Which comes to the reason why I'm talking to you dressed in this dripped out jumpsuit. I'm here in front of G-Force One, the 727 flown by Go Zero G. This plane gives passengers the real-life experience of weightlessness. The same sensations that astronauts feel on the ISS, the Moon, and Mars are replicated right here on Earth in a series of flight maneuvers. This plane will take me up into the air, going through a series of parabolic motions. Each parabola will allow me to experience both G-forces as I shoot up, followed by 15 seconds of true zero gravity, or weightlessness. Simply put, this is a roller coaster in the sky. However, there won't be any seats to keep me 10 toes down. The rest of this journey is going to show you a first-hand experience of what an astronaut feels like in space. This is me, the Hip Hop M.D, going zero G. Wow, that was absolutely amazing. I just felt firsthand the sensation of what an astronaut experiences in space. Thrilling, exhilarating, epic. Just don't describe what it feels like to face zero gravity. The feeling of no forces acting upon your body, being able to flip, jump, and spin without exerting any type of energy, just absolutely effortless. This feeling just gave me a greater appreciation of the gravity that we face right here on Earth. So now that we've cleared up the common myths about gravity, think about the effects that this downward force has on our day-to-day life. So when someone asks you, are you down, or what's going down, you can easily respond with, well, I'm always down for gravity. I'm the Hip Hop MD. This is Hip Hop Science, reminding you as always that curiosity is nature's PhD. Never stop asking.